All right, welcome back. In this example, we are given the region bounded by y equals x, y equals 0, the x-axis, and the line x equals 4. We're going to take that region and we're going to revolve it about the x-axis. And this time we're asked to compute the volume using both of our methods, shells and washers. So first of all, we recognize, of course, that we're dealing with this region right here. All right. And we're now going to be taking this region and revolving it about the x-axis. So we're asked first to do this with shells. So remember the process for shells. We take our rectangle and we lay it parallel to the axis we're revolving about. So for shells, that would be, in other words, this picture here. And so for shells, if we're going to be revolving about the x, we'll of course be integrating along the y-axis. Right. So our subdivide would actually be between 0 and 2. That means we're going to need to take this square root function, translate it over to being a function of y. So we take our y equals x squared of x, and we could write that down as x equals y squared. And then we notice that in this case, our shells, the length of our shell is going to be the difference between the line x equals 4 and the x value, which is x equals y squared. So doing it with shells, we would have our volume, which would be the integral from 0 to 2. Again, going back to our picture here. All right. Oops, get rid of those marks. 0 to 2, right? Along the y-axis. 0 to 2. And then again, we have our shell, or our sample shell, that shows us that the function that we're dealing with, this length is just the 4 minus x squared. Right? That's going to be our length. Or not 2x squared, but rather 4 minus y squared, sorry. It's going to be our function. That'll give us our height of our shell. And so we use our shell formula. 2 pi y times 4 minus y squared dy. And again, the way you do shells is it's always going to be parallel to the axis. If you're doing disk, then you're going to be measuring the radius, which is perpendicular to the axis you're rotating about. Okay, but here we're doing shells, so it's 2 pi, the variable, and then times the function. So we have some simplifying to do. I'm just going to pull the 2 pi out front. Integral 0 to 2. That would leave me with 4y minus y cubed dy. And then we just carry this integration process through. So 2 pi on the outside, integral of 4y would be 2y squared minus 1/4 y to the 4th. And then we're going to evaluate that between 0 and 2. Between 0 and 2. And when you do that computation, if you plug in 2, you're going to get y squared is 4, 2 times 4 is 8. When you plug in 2, 2 to the 4th will be 16, times 1/4 will be 4. So we're going to have 8 minus 4 is 4 times 2 pi. We're going to have a volume of 8 pi cubic units. Okay? And then we're going to do the same thing in part B here when we do it with washers. So to do it with washers, right, we're going to be looking at measuring perpendicular to our axes. So if we measure perpendicular to our axes, we're going to be measuring like that, and we're going to be integrating along that axis. So we're going to be going from 0 to 4 along that axis. And notice we actually don't even need a washer, we can just do a disk. We can just do this with a disk. And so the function here is square root of x. So using washers or disk. Disk is just a special case of a washer. It's touching the axes. We would do here in part B, volume, remember, is pi times the integral. In this case, it would be 0 to 4 of our radial function, which is the square root of x function squared, times dx. And so we work this out. Pi integral 0 to 4 x dx equals pi times 1/2 x squared evaluated between 0 and 4. And of course, when you plug 4 in, 4 squared is going to be 16. Half of 16 is 8 times pi. We get the same answer, 8 pi. Now, in this particular problem, the washer method probably was slightly easier integral, but really either one of these is probably fine. Either one of these is probably fine for this particular problem. Neither one's super complicated, but the important thing is to see that both ways we do get the same volume. We do get the same volume.